Good morning. We'll start today again with section 1123, day 2. The first question is a warm-up about all of the different angles and the type of angles compared to a circle. Recall there's 4 different type of angles. The first one is a central angle, and with a central angle is equal, the central angle is equal to the intercepted arc. The second one is an inscribed angle, where the inscribed angle is equal half of the intercepted arc. The third one is the interior angle, which is to make sure that you do your bow tie and it's equal half of the sum of the 2 intercepted arc. The last one is an exterior angle, and we said it's equal half of the big arc minus the small arc. So let's look at angle 7 and figure out what type of angle is angle 7. So angle 7 is right here, where the vertex is clearly inside the circle somewhere. It's not on the center of the circle, but it's inside the circle somewhere. So I'll do a bow tie that makes the 2 angles. But those two arcs, which is this first arc and this second arc here, they're not given to us at this point. So you want to figure out what's the measure of this arc and what's the measure of this arc. So the first arc here, which is here, the one in blue at this point, it corresponds to that inscribed angle. So if this inscribed angle is 15, then this arc must be 30. Now, if I go to the second arc, which is this arc here, which is in pink now, this arc here corresponds to this inscribed angle. So if this angle is 28, then the arc would be twice of the 28, which is equal to 56. So now I have the 2 arcs, the 2 arcs that make that interior angle. So let's just redraw the interior angle again. So you have the first one is 30, the second one is 56. So it will equal half of the 30 plus the 56. So I'll do 30 plus 56. Add them up together, it's 86. Divided that by 2, it's 43. Let's move on to angle 8 and figure out what type of angle is 8. So angle 8 is placed outside the circle, so it means it's the exterior angle. And with an exterior angle, I'll extend my 2 rays to figure out what the 2 rays, or what the 2 arcs that makes that exterior angle. So when I extend my 2 rays, the 2 arcs that makes that exterior angle is this one here, so the 56 and also the 30. So I'll do half of, the rule is the difference between the 2 arcs, so half of 56 minus the 30. So I'll do 56 minus 30, and that's equal to 26. 26 divided by 2 is 13. So that exterior angle is equal to 13. Make sure that you're trying to figure out what's the location of that angle so you know what rule you can apply. Measure of angle 9. Measure of angle 9 is right there. And the vertex is on the circle. So eventually, if the vertex is on the circle, then it would be an inscribed angle. And with the inscribed angle, it's equal half of the intercepted arc. And we do know that the intercepted arc is 56. So it would be half of 56. And that's equal to 28. Last question in that warm-up, angle 10. And angle 10 is right there. Angle 10 is the inscribed angle, it's an inscribed angle, and the intercepted arc is half of a circle, which is a semicircle. So the measure of this semicircle, the measure of this arc is 180. And since it's an inscribed angle, then it would equal half of the 180, which is equal to 90. Today, we'll change our focus to chords, secants, and tangents that's related to a circle. So we completed all of the different angles that's related to a circle, which is where there were 4 types of them. The first one is central, inscribed, second one. Third one is interior angle. The last one is an exterior angle. The first type So now we're shifting gears at this point to chord secants and a tangent in a circle and how they're related to a circle. The first case that we're going to be looking at will be eventually this first case. We did talk about it before when you have two chords in a circle, and we did try to do two triangles. And with those two triangles, those angle A and angle B, both of them are equal to each other because they share the same intercepted arc, DC. Not only that, you have angle D and C. They're equal to each other because, again, they share the same intercepted arc, AB. So those two triangles are similar to each other by angle, and you can write a proportion to figure out any missing piece out of the two chords. So AP over PD is equal to BP over PC. Let's find the X in this circle. With this X, I'll make sure that I'll put down again which angles correspond to each other, so I would know exactly how to write my proportion. So those two angles are equal to each other because, again, they share the same intercepted arc. It's easier when you're trying to do it color-coded, so in order for you to see which side corresponds to which side. Also, those two angles correspond to each other or equal to each other because they share the same intercepted arc. And finally, those two angles are equal because they are vertical angles. Now I'm ready to write the proportion. 4 from the first triangle it's between the blue and the red, so it will correspond to the side that's between the blue and the red, which is 7, and that's equal to 5. The 5 is between the pink and the red, so it will correspond to the side that's between the pink and the red, so 5 over X. Doing my cross and multiply, so I have 4X is equal to 7 times the 5. 4X is equal to 35. Dividing by 4 on both sides, so X is equal to 8.75. Here is the second case for segments to be related to a circle, and with this case, you have two secants that meet in one point. If you look closely at this circle, you will see that the a secant in general, it's a line that intersects the circle into 2 points. So you have the two secants and they're like connecting in one point, which is I. With that, when you have two secants, then the rule is exterior times the whole equal exterior times the whole, which is the whole secant or the whole segment. So if I look at exactly how to write the rule for this one, the exterior part from the first secant is IE times the whole secant is IS equal to the second secant, the exterior part is IT times the whole secant, which is IZ. So with two secants, you will do exterior times the whole equal exterior times. Moving on to this question, here I can see a case of two secants that are meeting together in one point. So the rule is the part that's outside the exterior part, which is 300 from the first secant, times the whole secant, which is 300 plus 600, equal to, from the second secant, you have 400 is the part that's outside, which is the exterior, times the whole secant, which is 400 plus the X. And from there, I can simplify further. So it would be 300 times the 900, which is equal 400 times 400 plus X. 300 times 900 is 270,000 equal to 400. I'll do my distribution. So 400 times 400 is 160,000 plus 400x. Now I'll subtract 160,000 from both sides. So 270,000 minus the 160,000, that's equal 110,000. And then finally dividing by 400 on both sides, 110,000 divided by 400, it's equal to 275. The last case is a tangent and a secant that meets together in one point. And with the rule of a tangent and a secant, so this is our third case. When you have a tangent and a secant, it would be the tangent squared equal to the exterior part of your secant times the whole secant. So the tangent squared in this diagram is RG squared equal to the exterior part of that secant, which is RE, times the whole secant, which is RE. The last two questions, both of them you have an example of a tangent and a secant. A tangent, again, is a line that intersects the circle in one point. A secant, it's a line that intersects the circle into 2 points. I'll start with the first question. So it's a tangent and a secant. So I'll do my tangent squared, which is 10 squared equal to, you have a secant, so the exterior part of your secant is a 5 times the whole secant, which is an x plus 5. Now simplifying further, I have 100 equal to 5. I'll do my distribution, so I'll have 5x plus 25. I'll subtract by 25 on both sides. So you have 5x is equal to 75. And from there, dividing by 5, x is equal to 15. And that concludes this question. Now let's move on to the last question, which is again an example of a secant and a tangent. And with a secant and a tangent, you take your tangent squared, so 6 squared equal to the exterior part of your secant is an x, and the whole secant is an x plus 7. Simplifying further, this is 36, the left side is 36. I'll do my distribution for my right side, so it will be x squared plus 7x. I'll subtract 36 on both sides, so x squared plus 7x minus 36 is equal to 0. If you try to factor this equation, it would be rough because there's no, you cannot find two numbers that multiply to get negative 36 and add up to get 7. So what would you need to do is try to apply your quadratic formula. Let me remind you again with the quadratic formula, it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying further, I'm going to look back again to my quadratic equation. For my a, it's equal to 1, my b is equal to 7, and my c is equal to negative 36. From there, I can simplify further. So I'll start by putting the values inside my quadratic equation or my quadratic formula. So it would be negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 36, and it's all over 2 times 1. Simplifying that further, it's negative 7 plus or minus the square root of, you have 7 squared is 49, negative 4, and you have, this is negative here, so negative 36 times the negative 4, it's 144. Plus the 49, that's 193 here, and it's all divided by 2. Simplifying that further, so you have x, after simplifying this one, the first equation would be x is equal to negative 7 plus the square root of 193 over 2, and the second one would be x is equal to negative 7 minus the square root of 193, all divided by 2. You have two answers at this point. X is equal to 3.445. And the second one, x is equal to negative 10.445. But I'm hoping that you can catch that a distance cannot be negative, so I can eliminate this answer, and your only answer for x is 3.445. At this point, you should be, after you're done with all of your notes, you should be ready to go and move on to, after you're done with your notes, upload them, and then you can start your homework assignment. Thank you and have a great day.